Today we will be discussing linear models. Linear models are used every day to show relationships between two quantities and are used for everyday practices like business and medicine. A good example for a linear model is trying to figure out how does money spent on advertising affect sales. Now, linear models demonstrate desired relationships and predict the likely outcome in many cases. Not included in the data. Scatter plots are used to show these linear models. Before we start, we should probably go over what linear models are. So basically, a linear model is a model that shows a straight line. Here are a couple of examples of linear models. Right here, as you can see, this is a straight line. So is this one, and this one. Now, examples of nonlinear models. So nonlinear models would be if you had a graph like this and your line was like this, or it was like this, or basically anything that is not in a straight line. So that is not linear and that is not linear. You can also determine whether a line is a good model for a given set of data points without graphing by using finite differences. Consider the following equation, y equals 3x minus 1. We know this graph is known to be a line. So when we look at this data table and see the differences between each y entry and the preceding one. So if we look at 2 and 5, we realize that they have a difference of 3. 5 and 8 also has a difference of 3, and so on. So, since the differences are all equal, we can see that the line should be a good model. Now, with what we've learned, we can finally put it to the test. We have a data table up here that shows a gradual increase of cash flow per share from 1988 to 1992. So to figure out if a line would be best suited for this data, we can either do method 1 or method 2. So method 1 is to find the finite differences. Now, like before, you're just going to subtract the y inputs. So if you do 279 minus 238, you get 41 cents. You get 44 cents from $3.23 subtracted by 279. Now this will continue to go on throughout the entire table. Now, with the information we have, we can tell that a line would be best suited for this data table because all of these differences. So we can either do method 1 or method 2. Now method 2 is just to graph our own scatter plot. So, with the data above, our x-intercept is going to be the years. And so we're going to let 0 be 1988, and then 1 is going to be 89, and so forth. So in 1988, the cash flow per share was $2.38. So if we graph it on here, it will be somewhere around there. Next, we are going to be graphing 1989, which is 279. So, go up a little bit. It's about there. 1990, 323. 323, about there. 91, 364, it's a little bit over that. And then 92 is $4.06. So 4, and then it's just a little bit over the 4. Okay. And with this, you can tell that it is linear because it is in a straight line or close to being straight. And both methods work efficiently, but if you don't want to graph, finding the differences is the best to do. But graphing is also very easy, and later on in the video I will be teaching you how to graph on your calculator so that you don't need to hand graph it each and every time you do it. Next, we will be discussing correlation coefficients. Correlation coefficients basically are used to show the measure of the strength and direction of the linear relationship between two variables, or you can say 2 points. So the correlation coefficient is always given between -1 and +1. +1 is being a perfect correlation in the positive direction. -1 is a perfect correlation in the negative direction, meaning this is sort of what it would look like. This is a perfect correlation in a positive direction and negative. Now, if we have 0, that means there is no correlation, meaning there isn't really a linear relationship between two variables. So I kind of drew just a regular graph, and I put scattered points all around because there's no correlation if you have the number 0. Now, you can use your calculator to find the correlation coefficients, and this, by finding on the calculator, it can tell you whether or not a linear model is best used for your data. Therefore, you won't have to handwrite your scatter plot each time. You can just plug your data into the calculator and it will show it for you. So I will continue to do that next. So basically now I'm going to use this data as an example for us to use our calculator, because you can do a scatter plot if you would like, but personally I feel these numbers are very small and it might be a little bit hard to get it as accurate as I would like it. So we're going to be using our calculator to find this. Basically we're going to turn it on, and first thing you want to do is do stat and edit. But before we do that for this, you're going to want to make sure that you are in scatterplot mode. So I'm going to do second y equals, and I'm going to press enter for this. And for plot 1, I have it on. I picked the first option, which is a scatter plot. I have my X list as L1, my Y list is L2, my mark is this, and I chose this color. So now we're going to do stat edit. So now that we have it in scatter plot mode, we can now put in the data we have. So you're going to press stat, and I just had it, stat here, stat, and then edit, which is number 1. And I already inserted all of the data, so I put the number of sides for L1, and the other numbers is L2. So we're going to calculate the linear regression line now to figure out what is the correlation coefficients. So from there we're going to go to stat calc. Okay. And we're going to press 4, which is line regression. So 4. And we're going to go all the way down to calculate. And there it gives us a couple of numbers that we can use and would be very helpful. So basically when we're looking at this, we're going to be looking at the R. We can tell that the correlation coefficient is best fit with a line, considering R, which is the correlation coefficient, is 0.999, which is close to being 1. Now, after this, we can also graph it. So I'm just going to press the graph button, and it shows a pretty straight line. So you can also tell that that is a good linear model. And if you do have any problems getting your graph for your scatter plot, you just press zoom 9. And it didn't do anything because I already pressed that before, but just a heads up in case it does not want to grab. So with these correlations, you can tell if a scatter plot is plotted like this, it has positive correlation. If it's plotted like this, it has a negative correlation. If it has points scattered all around, it has no correlation because it doesn't show an increase or a decrease. And this straight lines like this also show no correlation because the x and the y variables do not affect each other, and it does not increase nor does it decrease, meaning these two have no correlations and these positive and negative correlations.